Well, how goes it, pre-calc folk? I'd like to say that I hope this is the last video I have to do for lesson 4.3. Part 6, it's kind of crazy, but when you're making videos, it's a lot different than being in the classroom. You know, I'm trying to make the videos between 15 and 20 minutes, and yeah, I mean, so anyway, it took a lot of videos, and this is the final piece, and I'm making the connection between two pieces. The first, 4 videos were just developing the unit circle. Like, all of those were just dedicated to, like, how's the unit circle come about from the 30, 60, 90 right triangles, from the 45, 45, 90 triangles. How do those come about? How do they apply to the circle? How do they get the coordinates? How do I get the degrees? How do I get the radians? And then how do I just do it on my own? Those were the first 4 videos, were just more, how does this work? Video 5 was how to use the unit circle to answer some questions pertaining to sine, cosine, and tangent. And now this last part is going to still do that. And you can see I have 5 questions up here, which I have floated around between making sure I do sine, cosine, tangent, cosecant, secant. The only one I left off is cotangent. And remembering that secant, cosecant, or cosecant, secant, and cotangent are the reciprocal functions to sine, cosine, and tangent. You can see that I mixed in degrees and radians, but one thing you're going to notice, those degrees and radians are not looking like they're on the unit circle. The unit circle goes 0 to 360, or 0 to 2 pi if I'm talking radians, and those are definitely bigger. So these are the examples that are considered more than once around the circle. I've also added I don't want to say difficulty, but just where I want you to be as a pre-calc student. I have my unit circle here as a guide. I don't have any labels on them. I should know them. If I'm a student right now, I should know the unit circle in terms of being able to look at it and kind of say, here's 30, here's 45, here's 60, here's 90, here's 120. I don't have to be fast. This is not a race. I have to be accurate. And then I have to know how to also do the radians and count those out. And I need to know the coordinates. Square root of 3 over 2, 1/2. 1/2 square root of 3 over 2. Square root of 2 over 2, square root of 2 over 2. If I'm anywhere in the circle, just kind of know where I'm at. Like here, okay, I'm left, down, negative square root of 3 over 2, negative 1/2. Knowing those things. And I'm going to kind of do that as I make the video to say, here's how I process it in my brain. And, just kind of go with that. And then I'm going to branch into, well, what happens, because there's going to be certain things where you're asked for sine, cosine, and tangent that aren't directly on the unit circle, and that's where I'm going to go next. And that's going to be the conclusion of this video. And the conclusion of the whole series of 6. And yeah, so let's talk first of all. And remind you that on this unit circle, cosine is x, sine is y, alphabetical order, and tangent is the y divided by the x. So when I look at question 1 here, and you notice I have my calculator out for the degree ones, I always want to know, so that one says, what's the sine of 480 degrees? First thing in my head, sine's y coordinate. So once I figure out where am I in this circle, I'm going to look at the y coordinate. Now, if I take 480 and I subtract 360, because 360 is a full circle, so minus 360, I get 120. Which means, this just means go to the 120 spot. 360 followed by 120. It's the same as knowing where's 120. 120 is right there. 30 degrees past 90. 90, 100, 110, 120. I'm doing sine, which means I need to know the y coordinate, meaning how far up is that? That's up square root of 3 over 2. So the sine of 480 is square root of 3 over 2. Now a little check you could do on your calculator to say, did I do that right? Is make sure your calculator's in degree mode and hit sine 480. it should say the decimal version of that, which is 0.866. I talked about that in one of the other videos. Okay, 1020. I'm going to do the same thing. Now, 1020 is a bit larger, so I'm probably going to have to subtract 360 a few times. Minus 360, minus 360. I got 300. I want something under 360. The first time I subtracted, I got 660. Still too big. And then got 300. I just need to know where 300 is. 300's right there. 30 degrees past 270. 60 degrees before 360. However you want to think of it, 300's right there. Cosine is x-coordinate. I need to know the x-coordinate right there. Well, that far over, that's half. Half to the right. Cosine's 1/2. And again, if you want to check, make sure that your calculator's in degrees. I was just doing it myself. And if I were to hit cosine 1020, I get 0.5, which we all know is a half. Okay, now for the next ones, I'm going to check. I'm going to show you how to do 3, 4, and 5 here in a minute. I'm going to change my calculator right now to radians for when I do the check. I'm not going to do the check first. In one of the previous videos, I think it was video 4. Can't remember. I'm making so many these days. I talked about how you do the radians. I talked about how you take this unit circle and you count it. The black, starting with the black points, going blue, blue, black, blue, blue, black, skipping the reds. Those are on what's known as a 1/6 count. If I start at the black points and go red, red, black, those are on a 1/4 count. So when I do these questions, I'm going to talk about, hey, which count are they a part of? Because I can tell by their fraction. So 17 pi over 6. Guys, if that's a 6, that's a 1/6 counter. It's not a 4. So here's the deal. When you counted the blue, blue, black, blue, blue, black, we went 1, 6, 2, 6, 3, 6, 4, 6. I got to count all the way to 17. Now, if you can be a little, like I said, got to look back at the other videos, but when I count the blue, and I'm going to quit saying 1, 6, 2, 6, 3, 6, just count 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, all the way around the circle's 12, and think about that. 12, 6 is 2, 2 pi. Keep going. 13, 14, 15, 16, 17. I'm right there. Now I'm going to write this one in a second. That's negative square root of 3 over 2, 1/2. And the reason I'm writing that in, to do tangent, I have to do division. I did mention to you in the previous video, if you divide it once, you shouldn't have to divide it again. By the way, this blue dot's connected to that blue dot, connected to that blue dot, connected to that one. Those 4 dots all have the same tangent, except some are positive, some are negative. So I should only have to divide it once. Now, if memory serves me, I think I did that division in the previous lesson, or in one of the videos. I actually might have done it in video 5. So if I squeeze that division in right up here, y divided by x, y divided by x. Please note, we don't divide with fractions in this class. We multiply reciprocals. So to save space, I'm going to put it right here. So I'm not going to divide. I'm going to times negative 2 over the square root of 3. This is automatically going to be negative, and when I multiply, first of all, I'm going to get negative 2 over 2 square root 3. The 2's reduce. I have 1 over the square root of 3, and I'm going to multiply by square root 3 over square root 3, which gives me negative 1 square root of 3 over 3. Please remember that square root of 3 times square root of 3 is square root 9. Square root 9 is 3. Again, I wouldn't be going so fast. We did this before. You got to look in video 5. So this comes out to be square root of 3 over 3 negative. And that answer goes over here. Okay, so that's there. Now if I want to do a quick check a minute, first thing, I'm not super familiar with the fraction square root of 3 over 3, so Square root of 3 divided by 3 is 0.577. So if I was to check the tangent of that, that's what it should come out. Remember, calculators and radians now. Tangent of 17 pi over 6. I should get negative 0.577, which I do. So that's that. Like I said, you can pause this, but again, this is in the previous video, so I'm going to get that out of there so it's not bothering me for other calculations that I'm going to do. Alright, so the last two things I'm going to do here before I change gears, let's talk this one. Now, first of all, I did put these in order. Cosecant matches up with sine. Cosecant's the reciprocal. So if I know the sine, the cosecants just flip, reciprocal. Now 10 pi over 3. You might be looking and say, hey, thirds, 10 thirds. That's not one of our counters. 10 thirds can be easily changed into sixth. 3 times 2 is 6. So if you times this by 2, it's 6. So if you times that by 2, 26th. I need to count 26th to find my location. Now remember, we already did this once, so once around's 12, 13, 14, 15, 16, 17, 18, 19, 20. 20's right here. That's 26th, 10 thirds. Okay? I'm not going to write this time. This point is negative 1/2 negative square root of 3 over 2. Now, sine to cosecant is the y-coordinate. It's negative square root of 3 over 2. That's going to take some work. Negative square root of 3 over 2 is the sine. The cosecant needs to be flipped. So the problem with that is it puts the square root in the bottom. You fix it. Times square root 3 times square root 3. And I'm going to write the answer over here because you should be getting familiar with this from last year and this year already. That'll be negative 2 square root of 3 over 3. Square root 3, square root 3, square root 9, 3. I'm kind of squeezing that in right there. I see that. Negative 2 square root of 3 over 3. And lastly, before I change gears, I'll pause and erase this. Secant. Secant's connected to cosine. Cosine's x. So if I know the cosine, the secant's the reciprocal. Now, this is fourth. 13 pi over 4. 13 fourths. That's the 1/4 count. So now if you go over here and count, I'm not going to go 1, 4, 2, 4, 3. I'm going to count 1, 2. Those are the red and the black. So starting here, here's 1/4, 2, 3, 4, 5, 6, 7, 8. 8 is once around. Keep going. 9, 10, 11, 12, 13. Right here. This x-coordinate, again, this is related to cosine. The x-coordinate is negative square root of 2 over 2. I'm going to write that down right here. Negative square root of 2 over 2 is the cosine. Secant needs to be flipped. And it's going to be the same thing here. It's going to flip and need to be fixed. So I flip it to negative 2 over square root 2. I will multiply it by square root 2 over square root 2. I'm going to actually do this one because I don't know if we've done this one. I can't remember. This becomes negative 2 square root of 2 over 2. Okay? Negative 2 square root of 2 over 2. The 2's reduce. And I get just negative square root of 2. Now, before I pause and erase some of this stuff and get ready for the next part, let's check both these answers. I forgot to check. Now, just a quick note, negative 2 square root of 3 divided by 3. Like, I need to know what that decimal is. That's negative 1.15-ish, so I got to be able to know what that decimal is to check that. The cosecant. Now remember to do the cosecant, I got to do 1 divided by sine. There's no cosecant button on here. So 1 divided by sine 10 pi over 3. Negative 1.15. So that one's right. And square root of 2, negative square root of 2, by the way, is negative 1.414-ish. So the secant, which is 1 divided by cosine. I don't have a secant button. So 1 divided by cosine of 13 pi over 4, negative 1.414. So everything's good. I mean, I got to check my work too. I'm not perfect. I could have definitely made a mistake here in all these little side calculations we have to do. So you should be able to answer those questions, and they always are asked. I didn't put the directions here, but they always say find the exact. If they say exact sine, exact cosine, exact tangent, exact, that means it's from the unit circle somehow, including these, even though we don't technically have a 480, 1020 degrees, 17 pi over 6. They're not on our unit circle, but they are more than once around, so they are basically there. Okay, I'm going to pause and erase this and show you one other example we need to be able to deal with. 1 second. Okay, so here, we're going to wrap up this video. I apologize, this one's probably going to be a little bit longer, but I got to wrap this section up. And this ends everything, and it provides your whole week worth of assignments. This is the cap of it all. So here's the set of directions now. This one says to list the 6 trig values for theta, passing through the point 5, negative 3. Now I want you to be very, very careful. You'll notice I erased my unit circle because I don't need it for this question. I want you to be super careful to saying, well, wait a minute now, this is pretty easy. You told us that cosine is x, sine is y, alphabetical order, tangents y divided by x. That's if you're on the unit circle. The unit circle is a circle of radius 1. The 0.53, 5 negative 3, that's not a radius of 1. That point, and I know this is incredibly small, like this unit circle that was over here was like super enlarged and to see it clearly. But the unit circle literally exists right here at the radius 1. So these are not unit circles, so you can't use the logic cosine is x, sine is y. You can't do that because this is larger than a unit circle. So here's what you got to do, and listen very, very carefully. It would be nice if we could get through this with one example. And I'll give all the details in that one example because this video is going to go long enough. So number 1, plot the point. That's 5 right, 3 down, right there. 5 right, 3 down. And I don't care, I did my examples in quadrant 4. I don't care if you're in quadrant 1, 2, 3, or 4. You do these directions. You're going to make yourself a right triangle, and you make the right triangle the same way every time. Once you plot your point, draw a segment directly to the origin. So, right there. And then secondly, directly to the x-axis, never to the y, directly to x. For me, that's straight up here. That makes a right angle right there, and your theta is the angle near the origin, right here. Now I'm going to label a couple things and I'll tell you what you got to do, but I'm going to explain, well, what happens if I'm in the other quadrants? You follow the directions. But anyway, this is 5 to the right, so that length of that side right there is 5. This is down 3. I must call this negative 3 to keep pluses and minuses in check. You and I need to find this hypotenuse in a second. We're going to do that with Pythagorean theorem. But again, the directions for making that, plot the point, go directly to the origin, and go straight to the x-axis. Folks, if I was in quadrant 1 with a point somewhere, directly to the origin, down to the x. If I was in quadrant 2, directly to the origin, down to x. If I was in quadrant 3, directly to the origin, up to x. You always go to x, you never go to y, and you make your right triangle and put theta near the origin. Now, I'm going to do Pythagorean theorem to find that missing side. It's going to be something like negative 3 squared plus 5 squared equals c squared. A squared plus b squared equals c squared. Guys, be super careful here. Negative 3 squared is always 9, not negative 9. So this is 9 plus 25 equals c. 9 plus 25 is 34. That's c squared. I'm not interested in c squared. I'm interested in c. So I square root both sides. And I get c equals the square root of 34. Now it is my job to try to break that down if it breaks down, meaning does a perfect square number go into it evenly? For example, perfect squares that I care about are 4, 9, 16, and 25. 36 is too big. I think we all know 4 does not go into 34 evenly, 9 does not go in evenly, 16 does not go in evenly, and 25 is just way too close. So that's as good as it gets. No decimals, exact answers here, folks. The hypotenuse will always be positive because it's not really directional. This is right, so that's positive. This is down, that's negative. Hypotenuse will always be a positive read. So now that I have those things, this is going to appear a little bit more like something we did prior to this very extended break. When we had regular right triangles and just listing the sine, the cosine, and the tangent of them, we had right triangles on our paper too, but they weren't on a coordinate plane like this. So here we go. Sine theta, cosine theta, tangent theta. We are using the old-fashioned SOHCAHTOA definitions: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That's why it's important that your theta is in the origin, so you're doing the right labels. The 5 is adjacent, it's right next to the theta. The negative 3 is opposite, it's across from the theta. And the square root of 34 is the hypotenuse, it's across from the 90. So as I say sine, I got to do opposite over hypotenuse. And some of these are just going to be a huge pain. It's negative 3 over the square root of 34. And you need to fix that by multiplying by square root 34 over square root 34. Kind of like we did some of the unit circle stuff, and that becomes negative 3 square root of 34 over 34. If the 3 and 34 were to reduce in any way, shape, or form, we would, but they don't. So there's final. The cosine will be adjacent over, oh, by the way, please make sure your sine's negative. Your cosine will be adjacent over hypotenuse. That's 5 over the square root of 34, not negative this time. That's 5 over the square root of 34. Now, I'm just going to skip right to this answer because you do the same thing as you did in the previous example. Multiply by square root 34 over square root 34. That's going to become 5 square root of 34 over 34. And last but not least, tangent. Finally, a nice one. Tangent's opposite over adjacent. Opposite negative 3 over adjacent 5. Negative 3/5. Now, I would normally go sideways here, but I just don't have a lot of room with these little boards. So down here, I'm going to do, because it says list the 6, which means I need the other 3. So I need cosecant, secant, and cotangent. They are the reciprocals to the ones, and they're in the same order. Sine, cosine, tangent, cosecant, secant, cotangent, they're in order. Now, please note, sine and cosine, we had to fix both of those to make them proper. You should not have to fix any of these. Go back to the right here. This answer would have been acceptable if we could leave square roots in the bottom. We'll go there. That's the easiest thing to flip. If you take negative 3 over the square root of 34 and flip it, you get negative square root of 34 over 3. There is your cosecant. Didn't leave myself a lot of room here. Let's fix that. We're going to apply the same thing to secant here. Secant goes with cosine. We already fixed this once. Take the prefix. Flip it. Square root of 34 over 5. And then last but not least, cotangent. That was the only one that was nice anyway. Tangent was negative 3/5. Flip it, negative 5/3. So there's how you handle what's known as a non-unit circle deal. You have to be, again, I'm going to repeat this. You got to be very careful with that and don't be like, oh, he said cosine was X, sine was Y, if you're on the unit circle. And this question is not. Way bigger than the unit circle. Okay? So anyway, that's how you do it. It shouldn't matter what quadrant you're in. You follow the same process. And you can re-look at this, re-listen. I hope I explained it in enough detail. And that's that. That'll be the end of 4-3, and that's going to take us through this first week of online learning. All right? All right, thanks for tuning in, guys.